All right, section 2.4, deductive reasoning. So remember in section 2.1, we learned about inductive reasoning, and inductive reasoning is where we made conclusions based on observed patterns, right? So deductive reasoning is a reasoning process where we draw a conclusion based on given facts. So this is the preferred reasoning method and the process that we'll use to prove theorems and other statements in geometry. All right. So in inductive reasoning, remember we went from specific to general, so we generalized based on specific patterns or observations, whereas deductive reasoning, we're going from general facts that we know are true and proving specific or making specific conclusions based on those general facts. And remember, inductive reasoning does have its place, but like I said, deductive reasoning is the preferred method if we have that option. All right, so the law of detachment, and you don't necessarily have to remember the names of these laws, but just remember that if you have a true hypothesis, or excuse me, a true conditional, and if the hypothesis is true, okay, so if the hypothesis of a true conditional is true, then you can assume that the conclusion is true, right? So the first part of this is it has to be a true conditional, right? So if you assume or are given a true conditional, then if the hypothesis is true, that means the conclusion must follow. Okay? So let's take a look at number 1. If there is lightning, then it is not safe to be out in the open. All right, so if there is lightning, then it is not safe to be out in the open. So then Marla sees lightning from the soccer field. Okay? So remember, if we're assuming this is true and the hypothesis is true, so we see lightning, right? That means we can conclude that it's not safe to be out in the open, right? And so if Marla sees lightning, then we conclude, hey, we should cancel practice, right? This isn't safe to be out on the soccer field. All right, so we can conclude that it is not safe to be out in the open. And I spelled safe incorrectly. Sorry about that. All right, number 2. So if a triangle is a right triangle, then the triangle has one 90-degree angle. So once again, we have a conditional statement if a triangle is a right triangle. So we have the hypothesis. Then the triangle has one 90-degree angle. So that's our conclusion. The triangle has one 90-degree angle. So then we're given ABC is a right triangle, right? So we have a right triangle, right, which satisfies the hypothesis. Therefore, we can conclude that the conclusion is true, right? So that must mean that ABC, angle ABC, has one right angle, right? Or triangle ABC has one right angle. All right. So here's a cleaner version of the answers. All right, so let's take a look at number 3. If cats prowl, mice will scatter. So the hypothesis, cats prowl. Conclusion, mice will scatter, right? So here it says mice are scattering. Does that match up with the hypothesis? No, it doesn't, right? This is actually the conclusion. So the law of detachment says if the hypothesis is true, we can conclude the conclusion must be true, right? But here, they're giving us the conclusion. And if we're given the conclusion, we cannot necessarily conclude that the hypothesis is true. Sometimes it may be true, but we cannot make that conclusion, all right? And so here we would say no conclusion. right, and that's, I would say, the biggest mistake sometimes people will make is if you're given the conclusion, people just assume the hypothesis, right? But that's not how the law of detachment works or how conditional statements work. All right, number 4. If a triangle has two congruent sides, then the triangle is isosceles. So if the triangle has two congruent sides, so a triangle has two congruent sides is the hypothesis, then the triangle is isosceles. So in what we're given here is in triangle DEF, side DE is congruent with side DF, right? Those are two sides of that triangle, right? So we have two congruent sides in a triangle, and that matches up with the hypothesis, so we can conclude that the conclusion must be true. All right, so triangle DEF is isosceles. All right, and then number 5, if you arrive at the theater by 2 p.m., you can see the show. So think about the hypothesis, the conclusion. And it says Julie arrived at the theater at 1:45. Okay, so I'll let you make a conclusion on this one, okay?